There's this idea of cue competition. So this was first discovered like a few decades ago with experiments on rats, where I think this was back when morals, or I don't know actually, maybe maybe you're still allowed to do whatever you want to rats even in science today. But yeah, it's pretty horrible. But they'd basically shock a rat while playing a loud horn over and over again, and then the rat would start to, through classical conditioning, right, associate the horn with getting shocked. So even when the rat would hear the horn alone, they could measure the rat's brain or whatever and see that it was expecting a shock and, it was having like a visceral fear reaction. So after they teach the rat to associate the shock and the horn, then they'll start basically playing the horn, showing a really bright light in the rat's face, and then also doing the horn. So they'll kind of do all three of these at once to try to associate, to add the additional association between the loud horn and, or sorry, the bright light and the shock. But basically, no matter how many times they do this, the bright light never becomes associated with the shock, which is the interesting finding here. And the way that this is normally explained is that, there's this theory of predictive processing that basically says the fundamental mechanism of our brain and how learning works is that our brain is constantly making predictions about what's going to happen in terms of, what sensory data we're about to have incoming. And then it compares that prediction to what actual sensory data we received. And then we either, have our prediction be correct, in which we gain more confidence in our predictions, or we experience prediction error when there's a gap between what we predicted and what we actually experienced. And that's when we update our model. So it's actually a lot like how ChatGPT is trained. So in this case, first the rat learned to associate the horn and the shock, right? So then later, when they play the bright light, the horn, and the shock, the bright light alone was already enough for the rat to predict the shock, right? So no prediction error happened. Because no prediction error happened, no learning happens. So even though that now every time that the rat hears the horn and gets shocked, it's also seeing the bright light, it never learns to associate the bright light with the shock. And I think this is actually the same exact mechanism that causes interference. Yeah, basically our brains are constantly picking up tons of data from our environment, right? And most of that data is just random noise that doesn't help us make any meaningful predictions. So our brain fundamentally, its task that it's always trying to accomplish is trying to reduce prediction error. And so if there's certain cues, this word cue basically just means some specific aspect of our sensory data that our brain can identify. So if there's some particular cue, like for example, a bright light or a horn that our brain identifies regularly reduces prediction error, then it's going to start becoming really sensitive to that and start really regularly sending attention to that. Whenever that cue pops up, our brain is going to pay attention to it. Whereas if there's other cues that seem to be completely irrelevant and they don't help us make predictions, then our brain just starts to basically turn down those cues and ignore it more and more over time. And this way, our brain can hone in and be really effective, right? It finds the things that work, ignores the things that are basically meaningless. When people's brain can't do this well, this is basically when people have schizophrenia, right? They're like seeing patterns in places where the patterns don't exist, and then they totally lose a grasp on reality. And so when a person first learns their native language as a child, right, the brain's totally lost. The brain has no idea, whether that language has cases or not, or whether it has pitch accent or tones or stress accent or whatever, right? So the brain basically has to look everywhere possible and like leave no stone unturned in order to figure out how can it actually understand this language and reduce prediction error. And there's some kind of natural attentional algorithm in the brain where, left to its own devices, the brain eventually discovers every cue in the language and doesn't miss anything, right? That's why native speakers all end up as a native speaker of the language. They eventually figure out every phonetic feature, every grammar feature, and everything, right? And being fluent in one language, like I said, doesn't prevent this algorithm from working, because a 6-year-old can get fluent in English, start learning Japanese from scratch, and still arrive at a native level, right? So basically, I think what happens with interference is, using system 2, the problem is that it actually works, right? So if you were just going to start doing ALG style immersion, where you don't learn anything about the language, you just jump in, you don't even know anything about the language, right? And you don't consciously try to understand. You're just using your brain's natural unconscious algorithm that kind of starts slowly flipping over stones one by one, trying to figure out what works in the language, what doesn't work. How can you reduce that prediction error and start actually understanding, right? But if you learn, like, okay, there's this little grammar formula that I can use to translate a certain target language grammar structure into English, then that will actually help you understand. You're going to use this conscious shortcut in your head a couple times, and your brain's going to go, oh, wow, this works. Before I was understanding literally nothing. Now, suddenly, I can actually make out little bits and pieces of meaning when I use this conscious translation process of trying to translating little chunks and things into English. And so now you've totally altered the algorithm. Before, the algorithm was going to kind of send this like probing mechanism. It probably slowly look for lots of little things, figure things out in its own time. Now you're artificially just like, go right here. And your brain goes right there and it's like, oh shit, look, this really works. And then now it's not going to go and explore all the other things that it would have went and explored, like maybe pitch accent or other little subtle things like this, because now your brain basically has found this thing that's so promising, right? So the other cues end up getting down weighted because something like pitch accent, right? Initially, it's not going to help you reduce prediction error. If your brain goes and listens for pitch for a couple days, it's not going to help it understand. You have to sit and listen to pitch for many days, like many hundreds of hours, before your brain will actually figure out pitch accent enough that it becomes like actually helpful in you producing prediction error. Whereas that grammar rule, it works right off the bat. So now that your brain's given something that works right off the bat, it's going to view the pitch accent as basically noise because it's not going to be nearly as effective as all the little shortcuts that you use for system 2. So this is one of the, maybe not the only, but this is what I view as one of the core mechanisms of how system 2 causes interference is you alter the inherent intentional algorithm by giving your brain little shortcuts it can use that actually work so well that your brain stops bothering to go and look in places that it wouldn't have looked otherwise. And I think I've talked about this before, but one of the most apt metaphors is AlphaGo versus AlphaZero. So I won't go into this too much, but the first machine learning or like first AI program or just computer Go program that was able to beat a human was that was able to beat the best humans was AlphaGo. So Go is a board game that has like a million possibilities of what moves you can make. So it's way harder than chess to build a computer that can actually beat strong humans at the game. And the AI company DeepMind in like 2006, 16 or something released the first AI program that could actually beat the best human in the world. And the way that they built it was they took data from many different like strong human players. And first they just trained a computer to try to simulate what kind of move a human would make. Similar to how it was basically like next token prediction, just like how ChatGPT is trained to predict what word is going to come next in a text, right? And once the algorithm got really good at predicting what move a strong human would make, then they started doing reinforcement learning, which is when the AI basically just plays against itself millions of times and gets better and better just by playing itself. So through this style of training, they were able to make an algorithm or a program that could beat even the best human in the world. And that's cool and interesting. But then a few years later, they built AlphaZero, which instead of first training it to predict what moves a human would make, they instead just taught the algorithm the rules of Go, just what moves were allowed, what moves were not allowed, and what is the winning conditions, like how do you win. And from zero, they had it just play against itself like millions and millions and millions of times. So it started off, making random moves essentially and being completely doing things that completely sucked. But over time, it figured out more and more how Go works. And it eventually got to the point where it could beat AlphaGo 100 out of 100 times. So the one that they started off training on human data, that one was still able to beat the strongest human in the world, right? But then this other one where they didn't give it any human data at all, it was able to beat the first one 100 out of 100 times. So you can ask yourself, right, for the first one that they built, where they started off giving it human data, and then after that switched to reinforcement learning. So when they went to reinforcement learning, it was just playing against itself millions of times, right? Why wasn't it able to get like infinitely good through just playing itself millions of times? And just like Sashian said, yes, AlphaGo literally had interference. So by being trained on the human data, it had certain biases that reinforcement alone couldn't overcome, right? It was given these biases of like, okay, some moves are just bad, other moves are good. And these biases were so strong that it was basically stuck at a local minimum and couldn't get out of it. Whereas AlphaZero had no assumptions, right? It just started purely from scratch. And so in a way, remember, there's some moves that might look bad on the surface, but when you have a higher level understanding, actually turn out to be good moves, right? And AlphaZero was actually able to discover these moves, whereas AlphaGo had these biases that let it not be able to find them. So I think it's the exact same way, right? System 2 interference is like you have these system 2 shortcuts that initially are really promising, but they actually have limitations, right? They're not the same as what the native speaker does, but they are so promising that your brain latches onto them. And then later it doesn't go and explore the areas that it would need to in order to get truly native, because initially those other areas like pitch accent or whatever don't prove to be nearly as effective as your little shortcuts at reducing prediction error. So that's what I think is actually happening here fundamentally as the mechanism of system 2 interference. So this actually comes to moving a little more in terms of like, okay, what should we actually do? Well, I think there's actually two different types of using System 2 to help your language learning process. What I just explained is one of them, but there's another one. That's different and a little more helpful. So what I just explained is kind of, you could say, training the monitor. So this is when you're like literally just thinking of what things mean, and you're manipulating the form of language a lot in your conscious mind, and you're creating conscious shortcuts and things like this. You're really just using the monitor. So the problem with the monitor, I mean, I don't even have to talk about this, but obviously training the monitor takes huge amounts of time and practice to reach native level accuracy, right? Like grammar rules are really complicated, right? So if you're handling them all consciously in your head, it's going to be really slow and it's going to take tons of practice. It's probably always going to be less accurate and less reliable than a native speaker's unconscious intuition. It also actively causes interference. So by doing this, you're basically precluding the possibility of doing it the way a native would. And so I think that this should only be used as a last resort once you've completely fossilized. On the other hand, there's this concept of the dynamic interface. So this is the concept from Nick Ellis, and it's basically saying that it's based on kind of research that shows that when you notice something consciously, your unconscious mind also notices it. So sometimes your unconscious mind notices things that you don't notice consciously, but apparently the reverse is not true, is what this hypothesis is based on. So it basically means your unconscious is like a superset of your consciousness. So anything that you consciously notice, your unconscious is also noticing it, and there might be other things that your unconscious is also noticing, but it doesn't make it a consciousness. So basically what this means is if you notice something consciously, you're guaranteeing that your unconscious is also noticing it. And what the dynamic interface says, so the dynamic interface, the reason why it's using the word interface is it goes back to this interface debate that's happened within the field of second language acquisition that basically says, what is the interface of conscious knowledge? And there's the zero interface or the non-interface position, which is Stephen Krashen's position that says conscious knowledge is completely separate from unconscious acquisition and there's zero overlap. And then on the other hand, there's the like strong interface position, which is basically skill building that says conscious knowledge just becomes unconscious intuition if you practice enough. But obviously, both of those are wrong. And the true answer is that it's somewhere in the middle, which is called the weak interface position, which is that conscious knowledge never becomes unconscious intuition, but conscious knowledge and using System 2 consciously, it changes the way that your unconscious builds the language. So there is some interface, but it's not direct and it's not like a one-to-one linear thing. So the dynamic interface says the specific way that the interface works is once you start noticing something consciously, then your unconscious mind kind of realizes that it's a thing. And after that, your unconscious mind still notices it even when you're not noticing it consciously. So this is what happens with pitch accent, right? If you do, like we can kind of view high variability phonetic training as this is kind of defining it loosely, but you could kind of view it as a form of the dynamic interface where what you're doing is using your conscious mind to make your unconscious mind notice something. So when you do HVPT and you're just over and over again trying to identify what pattern you heard, you're forcing your unconscious mind to become aware of certain patterns. And once your mind is aware of those patterns, now it's actually storing pitch accent information, even if consciously you're not paying attention to it. Whereas for most learners that have interference, when they listen to Japanese, their brain is not storing any pitch accent data. It's just kind of ignoring it. So what I think is for things that are commonly not acquired based on your particular like L1, L2 combo, it's probably a good idea to intentionally notice these things early on. So for Japanese, this is really just pitch accent. So basically, whether we view it as due to a lack of brain plasticity or a lack of interference, like in reality, like I said, your brain is less plastic as an adult that's over 20 years old. And so, you are going to be kind of dragged into the patterns of your native language more than the 6-year-old. That is a reality. And also, it's also a reality that trying to reduce interference to zero is just not realistic. Like even people doing ALG end up still thinking about the language in your head because as an adult, you consciously think about things every day, all day long. And so you can't just shut that off. So you should still try to reduce interference, but you should expect it's not going to be at zero. So it's not realistic to expect that you can have a 100% ceiling, same as an infant. Plus, there's the plasticity thing as well. So I think, yeah, for pitch accent, we know that it's hard for people to acquire pitch accent. It's one of the first things that flies out the window when people get interference. And so it's probably good to do something like HVPT to train your brain to hear these patterns, right? But the thing is, you want to keep things light because, like I said, this mechanism here of you can consciously notice something and it will actually help your brain acquire it more. That's also the exact mechanism of what causes interference, right? Like I said, you pay attention to certain shortcuts in your head, and then those become so promising that your brain ends up not exploring other things that it eventually would need to, but initially are less promising. So I don't think you have to worry about this too much because again, we're only consciously paying attention to things that normally our brain would ignore. So you're kind of just balancing things out based on the patterns of your native language. But again, you still want to keep things light, right? So that's why you probably want to train yourself to hear the pitch accent patterns. And then after that, don't think about it too much, right? Or if there's a specific grammar thing, like for Japanese people, they have a really hard time acquiring like when to use a versus the versus nothing, right? So for them, they know that for Japanese people learning English, that's going to be something really hard to acquire and is very susceptible to interference. They probably want to maybe just be a little more conscious of that early on, pay a little bit more conscious attention to it to kind of seed it in their unconscious mind so that through that dynamic interface, the unconscious mind notices that it's a thing a little bit earlier. And that way they're actually able to acquire it. So in this dynamic interface, you're not trying to do it consciously, right? So the difference here is you're not trying to have a conscious model of pitch accent and speak pitch accent like with the right rules and the right everything consciously. You're just using your conscious mind to notice pitch accent and learn to hear pitch accent so that then you acquire it unconsciously. That's the difference between this dynamic interface and the training the monitor. So for a Japanese person, you're not trying to memorize all the rules that go into when you use a versus the and what all the exceptions to the rules are and all these things. You're just kind of noticing that that's a thing, knowing that okay, sometimes you need to use the, sometimes you need to use a, sometimes you need to not use either of them, and you just kind of pay a little more attention to that. You just notice, okay, there's a the just now. Oh, there's a just now. Oh, there's neither just now. But you don't think about the rules that much. You just notice that it's happening a little bit more. And that might actually make your brain start to notice them more, even when you're not consciously paying attention to it, according to this dynamic interface kind of hypothesis. So that I think is a good thing to do. Training the monitor is again like a last resort because it actually causes interference actively. So this is overall what I think the to kind of actually give you the succinct answer to your question, Lamont. So for the most part, I think you should focus on minimizing interference, maximizing your identity motivation to give you the highest chances of acquiring as much naturally as possible. But for anything that you is a known problem point for you, you might be learning a language where not many people have learned it, and so it might not be as clear what the specific points that would most likely to be problem points are. But maybe you can still make very educated guesses based on similar languages and what people tend to struggle with in those similar languages. And so try to take advantage of the dynamic monitor and like lightly notice the things that you think are likely for your brain to overlook. Remember, in a light, just noticing type of way. You're not consciously thinking of all the rules that much. And then the other thing is you want to start controlled output relatively early on so that you can get recasted. And that's another mechanism for taking advantage of the dynamic interface to start actually acquiring things that your brain just missed, right? So one of the reasons why I put in the current MBJ method roadmap, I put controlled output pretty early is because if you output and you get recasts, then your brain's going to be forced to start noticing whatever it's totally missed, right? Because you'll get corrected on it, you know? And again, with recast, you're not consciously thinking of what the rule is. You're just becoming aware, okay, something that I said with whatever, if it was a tense or a word or whatever, there's something wrong with it and it was supposed to sound like this. And through that, you're going to naturally start noticing it more in your immersion and then you can actually acquire it. So for some things that you just know, okay, it's likely I'm going to miss this, you can kind of be on the lookout. There's also going to be some unique things to you, right? Sometimes you just acquire something most people struggle with. Sometimes you just miss something that most people don't struggle with. So the output is the kind of net that catches anything that fell through your acquisition. And then once you've kind of reached whatever level you're able to reach and you've completely plateaued, completely fossilized, hopefully you're pretty much at a completely native level, but there might be some little tiny things like maybe there's just certain words where you acquired them wrong. Like even in English, I know for a long time I said pronunciation instead of pronunciation, and I just used the monitor to fix that, and kind of build a new habit of saying it the right way. So at the very end, you use the monitor to fix anything that fell through the cracks, even like natives have to do because there'll be some little things you just learned wrong, but hopefully it should be pretty minor. So that was my very long-winded answer.